read through this with you. Then you're going to pause the video and you're going to do it yourself, because we've done so many like this. I think this is a 2022 November exam, and it's pretty much the same sort of thing. STD, no. Standard temperature, pressure. I don't want STDs in physics, please. Standard temperature, pressure. Okay. The reaction between 1.5 grams, you're making a shopping list, hey, of magnesium, and check out magnesium. Oh, it's my favorite number. 24 on the periodic table. An excess of dilute hydrochloric acid, that means it's maybe 40% or 20% to volume, or 20% volume, 40% volume, is represented by the following balanced chemical equation. Yeah, it's balanced. What does that tell us? Ratios. So I've got 1 as a coefficient here, 2 as a coefficient here, 1 as a coefficient here, 1 as a coefficient here. The magnesium solid and hydrochloric acid, obviously it's a solution. 1 magnesium chloride, or chloride, and H2 gas. Define 1 mole. Calculate the mass. Now look at how many marks are allocated. Calculate the mass of MgCl2 that forms. If I need to find I'm going to make my shopping list. I'm going to get a triangle, a formula, and that formula is going to probably lead me to a ratio, because it's a balanced chemical equation. And after that ratio, it's going to lead me again to finding the mass, to the mass in grams. The volume of H2 gas that forms. Okay, so think about volume. What formulas do you have for volume? Make your shopping list. Shopping for a formula or two. Concentration of hydrochloric acid used if the volume, now we're still doing shopping lists, is 0.15 cubic decimeters. 7.3. The molar mass of hydrated sodium carbonate. Okay, hydrated means there's water of crystallization in it. Okay, the formula for the hydrate is Na2CO3, and a certain amount of molecules per 1 Na2CO3. There's how many molecules, maybe there's 5 water molecules per 1 Na2CO3s. Calculate the number of moles of water crystallization. So you're going to take the wet, the dry. They told us what the dry is? No? Okay. Represented by X in the formula above. Okay, well that's an interesting thing. Very interesting thing. The hydrates. What is this? Molar mass. Okay, the molar mass of the hydrated sodium carbonate. So that's the hydrates. Already given us the hydrates. Well, you would work out the molar mass of Na2CO3 from the periodic table. That will give you grams per mole. And that would be without those a water of crystallization without the water in. So without the water, when it's dry, what is the grams per mole? When it's wet, when the water vapor is still in it, then subtract them to find out how much that water weighed. After that, you can talk about, I suppose, a ratio of something to something, and then divide it. Okay. Again, define empirical formula. There is I think a 98.2% chance that you are going to get define empirical formula in your India exam for 2 marks. Okay, and please answer that, and then we'll go over the answers. I'll go over the answers in a bit. So you're going to pause this all at the end, and you're going to do it all, and you're going to see if you follow the right yellow brick road. Calculate the empirical formula, the simplest whole number ratio of substance for the percentage composition. Okay, so we've got this percent hydrogen. Look, okay, we don't have an oxygen, but we got carbon, we've got hydrogen, and we've got chlorine instead of oxygen, and that's okay. So how would I do that? Well, I make my shopping list, and I assume 100 grams of that. Then I make my shopping list, find 2 or 3 or 4. It would be like a table. Remember when I did that table of CHO? And then I said this grams, grams, grams. And I said N is equal to M over M. And then I made it into a formula of percent this to this to this. If you get something like 0.01 or 0.02 or something, it's very, very close. You round it off to a whole number. Okay, so pause this quickly, and then I'll go through the answers. I can go through them, or I can just write them out, but I'll go through them. So pause. Okay, to find 1 mole, the amount of substance, it's for 2 marks, that contains the same number of particles. I'm going to get a mark for same number of particles as there are atoms in 12 grams of carbon 12. So everything is kind of a uses that as the stencil, as everything is weighed against 12 grams of carbon 12. Okay. Then calculate the mass of magnesium chloride. Okay, cool. So I've got N is equal to mass over mass. Now let's see, the reaction between 1.5 grams of magnesium is represented like this. Okay, cool. So 1.5 of magnesium, this is N of magnesium, and I need to, let's calculate the mass. I think, calculate the mass, oh yes, of 5 marks. Okay, M of magnesium, so the number of moles would be 1,5. The mass of the whole substance, not just mg. Okay, cool. 1.5 divided by my favorite number, 24. So N would be equal to 0.625. Yeah, I like that. 48. Yeah. Mole of, what am I busy with? Please write this in. Don't just write mole, because you might confuse and you might think this is Cl or something. Okay, then I've got a balanced chemical equation. Whenever I've got a balanced chemical equation, standard temperature, pressure, whenever I've got a balanced chemical equation, I know that I'm looking at my coefficients of those molecules or those compounds to make them in a ratio to each other. So I'm going to look at magnesium, and I'm going to look at magnesium chloride. So this is my reactant. It reacts, reactant, that's product. So they are in a ratio to each other. So I can take magnesium. So I've used a formula mark there, one more mark. This is for 5 marks. You won't get formula mark twice, I don't think. So between here, this mark might be given in the substitution again. The next formula. So magnesium 2. What's my product after the chemical reaction? MgCl2. I've got 0.0625 moles of that. And my ratio is 1:1. And if my ratio is 1:1, I'm not a huge fan of this. I hope this isn't a weird question, because I've got this many moles of this. Now I've got magnesium and chloride, and if it's 1:1, I'm looking at it is balanced at 0.625 moles of whatever this is, and that's okay. I'm sure it's right. Okay, I mean the question. So I've got this to this because I got 1:1. You see, I got one coefficient 1:1. Yeah, that works. And so 1:1, which means I've got this many moles of this many moles of MgCl2, which means I can get, and what am I looking for? I'm looking for the mass. So I need this formula. They won't give you 2 formula marks though. In this, they already gave one. So this is this stuff is equal to, they're looking for the mass, so I need to find my my molar mass of this guy, which is going to be 24 plus 35.5 times 2 is 71. Am I right? I think I'm right. 71. Yeah. So this together, 24 and 71, is 95. So I'm going to say times 95, both sides. So this equates to 95 times 95. And 95 is almost 100 of them, which is, so I'm going to have, if I times 95 both sides to 2 decimal places, I'm going to have a mass of 5,9394 grams of MgCl2. And there you go. For 5 marks, you've gotten a formula, a ratio, a formula. There you go. Bob's your uncle. Okay, so I have you made a shopping list. I'm looking for volume. And my volume, I've got Volume, I've got concentration, but that doesn't look quite well because I've just found out my moles of. Oh, I can find out my moles. Everything except this one is ones. The coefficients are all ones. So if I've got 1 mole if I've got 0.0625 moles of magnesium, my reactants and my products are going to look a little bit similar. So I want my volume. I'm going to shop for a formula that's going to work. Molar volume, that's a constant, 22.4, and I'm going to say 0.0625 is equal to the volume, which we're going to work out, divided by 22.4. So I'm going to times both sides by 22.4 times 22.4. So therefore my volume is going to be 1.4 decimeters cubed, and that's of H2 gas. That wasn't difficult. 3 marks. 3 marks. Okay. If you got this wrong in one of the others, but you shouldn't have. But if you did, they often mark. They only take away 1 mark earlier on, like in 7.2.1. And if you put that wrong thing in here, they still mark it right. But I don't think you won't get it wrong. You'll get it right. Enough practice and you can kick that ball perfectly in the actual final soccer match. Because math is a verb. It's a sport. You've got to do it a lot. You've got to practice it a lot. And science is math applied. I'm speaking quite softly because it's now 1:45 on a Sunday morning. So, what have I got? 7.2.3, concentration. So, I've got concentration. C is equal to, concentration is moles over volume of hydrochloric acid. So, I've got the moles of hydrochloric acid. I've got 0.0625, which we found out before. Let's not do that. Because I need to read this properly. Concentration of hydrochloric acid used as a volume is 0.15 cubic decimeters. Okay, so concentration is going to be 0.15. Now, concentration of hydrochloric acid used if the volume is this. Did I change my volume at all? Let me quickly look at this a little bit more. Okay, so hydrochloric acid, can you see that its coefficient is 2? So hydrochloric acid to H2, we've already established that we got this 0.065. So say for instance I got H2, and let's put hydrochloric acid afterwards, even Mg. Mg to hydrochloric acid. We can take reactants to reactants, reactants to products. But this, if I take this Mg and I put it in a ratio to hydrochloric acid, my Mg is going to be 1. Hydrochloric acid is going to be 2 because of my coefficient there. So this is going to be 0.0625. What's double? 0.0625. Well, 6 and 6 is 12, so 0.125. Oh, yeah, 0.1250. Can you see this one's double this? I can just double that. So 0.125. I knew there was something weird happening here. So that's why it's very good to do this. To say after everything what it is. This is of the magnesium, but it's not of the hydrochloric acid. So always note to self, always put at the end what you mean. H2. The moles of Mg. Okay, so this is going to be 0.125 divided by 0.15, which is the concentration is going to be equal to 0.83 mole per cubic decimeter. Okay, and that one was for how many marks? That one was for 3 marks. Okay. The molar mass of, is it the same thing? No, it's different. The molar mass, of the molar mass. Come on. Of hydrated sodium carbonate is 268. So I've got water crystallization happening there. It's the hydrate. So 7.3. My hydrated sodium carbonate is going to be 268 grams per mole. And the hydrates, number of moles of water of crystallization represented by X in the formula above. So I'm going to take NaCO3. So Na is 23, carbon is 12, and 3 times 16 is 48. So that gives me 60, 83. But how many NAs have I got? Let's see, I've got Na2, so I've got 2 times 23 plus one of those plus that, which gives me 106. So the big mole of the big M of Na2 CO3 is 106 gram per mole. Gram per mole. Okay. Then this is the dry, and you're going to say this is the dry, or the dry version is called anhydrous, anhydrate or anhydrous, and this is the hydrate. So to find my water of crystallization, I'm going to take the hydrate minus the anhydrous. So I'm going to say it's 268 minus 106 is going to be how much? 162? 162? No. 162 grams per mole is my, please say what you just worked out. That's my H2O. That's my water of crystallization. That I heated this up and it evaporated. It's the difference between the hydrate and the very dry salt. Okay, so what's the real question? Calculate the number of moles of water of crystallization by X in the formula above. Okay. Moles of crystallization, I've got 162. But we're not done yet. I've got 162 moles, and I need to get calculate the number of moles. I need moles. How do I get moles? I'm going to divide I can get moles a few different ways, but I can divide this thing again by its grams per mole is the bottom. Mass in equals, and I needed what? Number of moles. I need this guy. So I've got I just want to divide this thing by 18 because I know that there's 18. The molar mass is 18 per molecule. So how many moles are there? So I'm going to say divided by 18. It's almost 2 in the morning, so I just want to divide this thing by 18 because H2O is 2 hydrogens plus 16 oxygen, which is 18. So my number of moles, calculate the number of moles. So my number of moles is 162 divided by 18, and 9 times 18 is 162. So I'm going to have X I've got this many grams per mole of the full amounts of H2O in this formula. How much does is this way in relative atomic mass? 18 altogether. So how many of these molecules are in this? I'm going to say there are 9. There's going to be 9. So X is going to be 9. So I'm looking at Na2CO3. This is not a times, it's saying water crystallization. 9 H2O. In other words, for every one of this substance, there's going to be 9 waters. I've got 162 grams per mole in total, and every one molecule is 18, so I divide by that to see how many molecules of this stuff do I have. Okay, let's go on. If you want to ask more about this, please do, because I could have explained it much better, but this is full. This is how many moles there are in the whole substance. Each one of those each one of those molecules is 18. So how many actual molecules in relative atomic mass, how many actual molecules are there in that grams per mole? Okay, so 7.4 again, describe empirical formula. It's the simplest whole number ratio of atoms in a compound. It's the simplest. The word simple is very important. Ratio of atoms in a compound. Okay. Let's see. So, but we got a Cl here, which is quite interesting. So I've got, let's say, I like carbon first. I'm going to put carbon first. Carbon, hydrogen, because I suppose because it's chlorine, you're going to put hydrogen first. Okay, yeah. So, because it might be hydrocarbon something, whatever. HCCl, assume, this is 7.5, assume 100 grams, which means that Hydrogen is going to be 4.07 grams. Carbon is going to be, 4.27 grams. And chlorine is going to be 6.5 grams. Then you're going to put your N is equal to M over M, which means N is going to be, you're going to follow the same route every time. They're going to ask the same thing with different numbers, or even with the chlorine. Every time it's the same thing. Okay, so I've got 4.07 divided by I've got hydrogen, cool, which is 4.07, and that's moles of hydrogen. Okay, then N is equal to 24.27 grams over carbon is 12. That's about 2. So that's 2.0225 moles of carbon. That's going to be 71.65 divided by chlorine is 35.5. It's good to know the basic elements. You don't have to be looking backwards and forwards through the periodic table, but just know them off by heart. So that's going to be 2.018 moles of chlorine. Now, these are good numbers. I love these numbers. They're not giving me bad energy, because we rounded off here. We probably rounded this grams off, this percentage off. This could have been 4.0732527. Because we rounded it off, there is a slight margin for error. Slight. If this was 2.25, that would actually be 2.25. Can you see that happening? It would be 2.25, which means you would have 2 times 4 is 8. You'd have 9 over 9. Sorry. You'd have 9 over 4, which means you would have to times all of those ratios by 4. But because you got a 0 here, it doesn't really matter. So if you got a number straight after the comma, put this back in your fraction button. Then you know what to times by the denominators of for all of these. But that's more grade 11 stuff. If you see it in grade 10, know that if you've got something like 7.5, well, you're going to go 15 over 2. You're going to do that fraction button. And you're going to times all the other ratios by 2, by 2, by 2, by 2, by 2. But if you've got 7.05, it's so small. It won't even be 0.05. It'll be 0.01 or 0.02. It's so small that it's not even. It's negligible because we rounded off earlier on. And the question actually rounded it off before we even got here. So I like these numbers super lots, super lots, because this is going to be I like carbon first. I'm going to put carbon first. CHCl. I haven't seen something where it's H. Yes, HCl, but usually it's CH something. So carbon will be 2.0225 to hydrogen, which will be 4. Can you see that's double? Loving it. 07. That 07 is quite negligible. And that is 2.018, also quite negligible. It could have been the rounding off of stuff much earlier on. And so you're going to put it into whole numbers. So you're going to say 2, 2. Let's not make it too small. Let's say 2, 2, 2, 4 to 2, but that's not simplest form. Simplest form would be divide everything by 2. So divide by 2, divide by 2, divide by 2, and I've got 1 to 2 to 1. Then, am I finished? Not yet, because I've got to put them in subscripts. So, for every, in this empirical formula, for every ratio, it's a ratio of 1 carbon to 2 hydrogen to 1 chlorine. Now, we don't write the ones here. I don't think your teacher will mark it, or the examiner will mark it wrong, but it's going to be CH2Cl. And that is for, how many marks is that for? That's for 5 marks. So, learn how to do it. You're going to assume that it's 100 grams. Then you're going to turn it into N is equal to M over M. Get it from your periodic table. Then turn it into a ratio. Simplest form, simplest whole number form. Simplest whole number form. Then put it into a subscript. And this is your empirical. I did ask for empirical formula. Hey? Yeah. This is your empirical formula. And it is officially formula. It's officially Sunday morning, 2:05 a.m. Signing off from East Coast Radio. Have a lovely day. And good. If you got them all right, fantastic. But do more exercise, because science is application and you need to practice it. Good job.